Okay, in this video we're going to try and cover the basic mastery questions from tutorial 7A. So we start with question 1. Question 1 gives us this differential equation, dy dx is equal to 1 take y. We're also told that y is going to be less than 1, and we're given a condition that when x is equal to 0, y is equal to 1. So for a differential equation, what we have to do when we're asked to solve it is we have to find the original function y that satisfies this equation, that is, that the derivative of y is equal to 1 minus that function y. Now this type of equation is called a simple separable differential equation because I can get all of the terms with y in it onto the left hand side and all of the terms with x in it onto the right hand side. That is, I can, by dividing by 1 over y, I can say that 1 over 1 take y, I can say that 1 over 1 take y dy is equal to 1 dx. However, mathematically this doesn't mean anything because dy dx isn't a fraction. I can't just move it up to the other side. So when I move it up, I have to say that I'm actually integrating on both sides of this equation. So this is nice. We know now that the integral of 1 over 1 take y with respect to y is equal to the integral of 1 with respect to x. So we know how to do this. This is going to be ln of 1 take y, not forgetting our modulus, divided by the derivative of y, which in this case is negative 1, so we'll just multiply there. And that's going to be equal to x plus some constant k, right? Now this is where our condition that y is less than 1 comes in useful because it means that 1 take y is always going to be positive. So this is the same thing as saying that ln of 1 take y is going to be equal to negative x plus some constant c. In this case, c is just negative k. Right, but I don't actually have to keep track, I just know that this is a constant still. So that means 1 take y is going to be e to the negative x plus c, and e to the c, this is actually the same thing as e to the x times e to the c, right? Where e to the c is a constant. So, I don't need that prime there, sorry. Where e to the c is a constant. So, hold on. So, what do I get? I let a equal to e to the c, and then I have 1 take y equals to a e to the minus x, or y is equal to 1 minus a e to the negative x. Now, I'm not quite finished because I'm told when x equals to 0, y equals to 0. So when x equals to 0, y equals to 0, that gives me 0 is equal to 1 minus a e to the negative 0, and that means that a equals to 1, if I work this out. And so that means my particular solution is y equals to 1 minus e to the negative x. Now, just a point to note here, right? This one here, this expression up here, is called our general solution because anything that looks like this will actually give us this original differential equation. Whereas the second one down here is called our particular solution because only this one not only gives us this differential equation back, but also satisfies the initial condition that when x equals to 0, y equals to 0. So with that, we are done with question